At 60,000 feet above the Earth, where the sky fades to black and the air can barely sustain life, machines operate that cost as much as a skyscraper. These are autonomous aircraft capable of flying for days, designed to cross entire oceans without human intervention. They represent the highest point of modern engineering. While most people associate the word drone with small consumer gadgets or flying cameras, there exists an elite class of machines that redefines what it means to fly without a pilot. Don't miss the finale. Because the last drone on this list isn't just the most expensive. It's the embodiment of what happens when budget is no object and technology knows no bounds. It all begins with a model that changed the limits of what was possible. The MQ-9B Sky Guardian, built by General Atomics, is the most advanced evolution of a family of unmanned aircraft that ushered in a new era of autonomous aviation. Each unit is valued at around $35 million, but its true worth lies in what it represents. It is the first large-scale drone certified to share civilian airspace alongside commercial planes. An achievement that took over a decade of development and safety integration. With more than 40 hours of endurance, the Sky Guardian can cross continents while transmitting real-time telemetry, multispectral imagery, and atmospheric data. Its efficiency, long range, and reliability have made it a blueprint for the next generation of hybrid aviation. But the scale grows. And with it, the challenge. The next leap in this evolution is the RQ-4 Global Hawk, manufactured by Northrop Grumman. This aircraft operates in the stratosphere, flying over 18 kilometers above sea level, far beyond commercial traffic. Each unit costs between $130 and $150 million. Driven by an array of sensors worth more than many entire airplanes, equipped with synthetic aperture radar, hyperspectral cameras, and long-range infrared detectors. It can monitor an area the size of South Korea in a single flight. With more than 34 hours of endurance, it can cross oceans non-stop. More than a vehicle, it is a flying data platform whose mission is to observe, measure, and transmit information that enhances aviation safety and meteorological forecasting worldwide. From that foundation, technology adapts to a far harsher environment. The ocean. There, the MQ-4C Triton emerges, the naval counterpart of the Global Hawk. With a price tag between $180 and $200 million per unit, it was redesigned to withstand salt corrosion, humidity, and powerful maritime winds. Its 360-degree radar can detect ships hundreds of kilometers away, even in fog or storms. Beyond surveillance, it integrates meteorological and oceanographic data in real time, making it an essential tool for modern maritime management. This marks the point where autonomous flight leaves solid ground behind and begins operating continuously over the blue planet. The next step takes autonomy to a completely new level. Its name, MQ-25 Stingray, developed by Boeing. Its role is not observation, but something even more complex. Refueling other aircraft mid-flight, fully autonomously. Valued between $200 and $250 million, it is the first unmanned aircraft capable of taking off and landing on a moving aircraft carrier. To achieve this, it combines artificial intelligence with precision navigation systems that operate within centimeters of tolerance. The Stingray proves that collaboration between human and autonomous flight is not only possible, it's the future. And then comes the summit of this technological climb. the RQ-180. For years, its existence was only a rumor, a silhouette glimpsed in the desert radar returns and whispered about in aerospace circles. Today, it is accepted as real, though its details remain classified. Its estimated cost reaches hundreds of millions per unit, with total development likely in the billions. This is not an ordinary drone. It is a platform built to fly higher, farther, and longer than any other. Its flying wing design eliminates vertical surfaces, reducing its radar signature to nearly nothing. Every edge, every curve is engineered to scatter radar and absorb light. The RQ-180 can stay aloft for over 40 hours, gliding silently like an atmospheric satellite. Its embedded sensors can map entire continents from altitudes unreachable to conventional aircraft. But its most impressive feature is not its reach or endurance. It's its intelligence. Its autonomous systems can analyze weather, make navigational decisions, and adjust flight parameters in real time. At such altitudes, every variable matters: temperature, air density, solar radiation, and the RQ-180 adapts to them all. Its structure is rumored to be built from nano-engineered composites, capable of surviving near-space conditions. Its wings act as a living antenna, sending and receiving data across oceans and continents. It doesn't just see, it interprets, computes, and communicates. Its flight marks the moment when engineering becomes art. The RQ-180 is not only the most expensive drone in existence, it is a symbol of how far human technology can reach when the sky stops being a limit and becomes an extension of the mind itself. These 5 systems don't just illustrate the progress of an industry, they reflect a larger trend: the total automation of the sky. In them, economic value is merely a consequence of accumulated knowledge. Behind every flight are decades of research in composite materials, aerodynamics, artificial intelligence, and data management. Their development is driven not solely by surveillance or defense, but by the pursuit of efficiency, autonomy, and resilience in extreme environments. The RQ-180 tops this list not just for its technological worth, but for what it symbolizes: the current frontier of unmanned aviation. From the Sky Guardian to this invisible platform, humanity has climbed a ladder of innovation where every rung redefines the relationship between machine and sky. The future may not belong to the fastest aircraft, but to the smartest ones, to those that fly tirelessly, learn from every mission, and turn data into decisions. The story of these giants of the air doesn't end in the sky. It only just begins there. Because when technology can operate without human intervention, flight ceases to be a feat and becomes pure science.